Let's take a look at this problem, number 19. Snow avalanches can be a real problem for travelers in the western United States and Canada. A very common type of avalanche is called a slab avalanche. These have been studied extensively by David McClung, professor of civil engineering at the University of British Columbia. Slab avalanches studied in Canada have an average thickness of mu is equal to 67. Now, oftentimes they give us mu because they're referring to the old value. So mu is equal to 67. The ski patrol at Vail is studying slab avalanches in this region. A random sample of avalanches in spring give the following thicknesses. Looks like we have 1, 2, 3, 4, 5, 6, 7, 8. So 16 total. So they're giving us n is equal to 16. Now, since they're giving us raw data, we're going to need to plug that in our calculator. So let's go ahead and do that. So go to our stat, go into edit, clear out L1, and we got 59, 51, 76, 38, 65, 54, 49, 62. Double check my numbers here. Okay, 68, 55, 64, 67, 63, 74, 65, and 79. Okay, just doing some last minute checking here. Okay, then exit out. Now, even though it looks like we have quite a few numbers, realize it's still a small sample. Now, it says use calculator with mean and standard deviation keys to verify this. You could go into one of our stats now that you put in L1 and see if that's true. But we don't need it for what we're doing. Assume the slab thickness has an approximately normal distribution. Use a 1% level significance. Kind of weird way what they're giving us there, but they're telling us that alpha is 0.01, 1%. That's your level of significance is always alpha. Does TESA claim that the mean slab thickness in the Vail region is different from that in Canada? Okay, so the claim is the mean is different than some value. Now, when they usually give you what they want you to compare it against up above, and here, see the way they told us mu is equal to 67. So their claim is the mean is different than 67. Okay. Step 1, write down a shortened version of the claim. We did that. Step 2, come up with a null and alternate hypothesis. Different than, that's not equal. And that symbol goes on H1. So mu is not equal to 67. And this one will be mu is equal to 67. Now step 3, see if your claim matches H0 or H1. Well, different than is the not equal, so obviously it matches H1. Now, I say use t-test, but t-test only applies if sigma is not known. And nowhere do they tell us sigma, so we're going to use t-test. Now, we've already input our numbers in, so we can go directly to the function. So I'm going to go to stat and go to tests and want to down arrow to t-test and press enter on it. Now, data is when you're given raw data, and that's what we got. So if yours isn't highlighted, put your flashing cursor on data and press enter one time. Mu naught is a number off of our claim, off of H naught, H1. They're all 67. So I put in 67. Now the list, this is where we put our data at. We put ours in L1. If you don't have L1 there, do second 1 to put L1 there. Now down arrow to frequency, and you should have a 1 there. If you do not have 1, press alpha to take off alpha lock, and press your 1 button once, and then down arrow. And this is a symbol on H1. Well, the symbol on H1 is a not equal to, so I want the not equal to selected. So I put my flashing cursor on not equal to and press enter. Then I'll down arrow to calculate and press enter. And our P is 0.0703, taking it to 4 decimal places. If P value is less than alpha, well, P value is 7%, alpha is 1%, so it's not less than. If P value is greater than alpha, which is true, then it says accept H naught. Well, if we accept H naught, that means we're going to reject H1, because they're opposites of each other. And since our claim matches H1, whatever we say about H1 is what we say about our claim. So we're going to reject our claim. And the answer is this entire piece. The answer is just not reject claim. Doing a hypothesis test, the entire process is your verification.